All right, welcome to the Explainer. Today, we're jumping into the engineering architecture behind BeeAI. From one engineer to another, we're going to unpack how this thing aims to solve what is, let's be honest, one of the biggest headaches in our field, the absolute chaos of deploying and managing AI agents. So, if you've ever actually tried to get an AI agent into production, you know this pain. It feels like you're navigating this completely fragmented mess, where every single project means you're basically reinventing the wheel for deployment, for monitoring, for communication. It's just a huge operational tax that slows everything down. And this chaos, it really boils down to two core problems. First, you've got this jungle of incompatible frameworks that create all these technical silos and just so much wasted effort. And second, there's the sheer complexity of deploying each agent. Everyone feels like this unique, fragile snowflake, and that creates an operational nightmare that just kills scalability before you even get off the ground. Okay, so how does BeeAI even begin to tackle this? Well, their whole solution starts with a really fundamental engineering principle, separating the act of building an agent from the act of running it. This distinction, this separation of concerns, is the key to their entire architecture. So on the build side, you have the BeeAI Framework. Think of this as your SDK. It's got the libraries and tools in both Python and TypeScript that you need to actually code your agent's logic, hook up its tools, and design its workflows. This is the workbench, right? This is where the AI and ML developers live. And then, on the run side, you have the BeeAI Platform. Now, this is the operational layer, and the absolutely crucial detail here is that it is framework-agnostic. By using standard stuff like containerization and a common protocol, it basically creates a universal runtime. And that means you can deploy and manage any agent that follows the rules, not just the ones built with BeeAI's own framework. That's a huge deal. And what this does is create a super clean separation of duties. AI devs, they use the framework to focus purely on the agent's intelligence, its logic, its tools. Once they're done, they can just hand it over the fence to the DevOps and platform engineers, and they use the platform to manage the agent's entire lifecycle. It's a clear, well-defined handoff between two totally distinct roles. And that really brings us to the project's true ambition. You see, the goal here isn't just to be another agent framework. No way. It's to do for AI agents exactly what Docker and Kubernetes did for software applications. Create a standard, commoditized, operational layer that completely decouples development from deployment. It's a strategic play for the entire ecosystem. Now, this whole build versus run separation isn't just for good architectural hygiene. It unlocks some incredibly powerful patterns. This is where we see the real payoff, being able to orchestrate entire teams of specialized agents to go after really complex problems. So the framework kind of guides you, almost forces you towards a mixture of experts pattern. You might also hear it called a hierarchical agent team. From a software engineering standpoint, this is fantastic because it helps you avoid building a single monolithic God agent that becomes impossible to maintain, impossible to test, and impossible to scale. So here's how it actually works in practice. You build these small, focused, independently testable specialist agents. One for weather, maybe one for stock prices, another for database queries. Then you create a main orchestrator agent, and its only job is to delegate parts of a complex query to the right expert. Then, at the end, it just takes all their individual responses and synthesizes them into a single, coherent answer. And the key piece of tech that makes this all possible is the handoff tool. It's pretty cool. When the orchestrator's LLM is thinking about which tool to use, it reads that description field. So a really well-written description, something clear like consult the weather agent for forecasts, allows the LLM to intelligently figure out which specialist agent to route the task to. It's a deceptively simple but incredibly effective routing mechanism that's powered by the model itself. So let's zoom out for a second. When you combine a universal runtime with a standardized way for agents to communicate and delegate tasks, what are you really building? What's the end game here? Well, BeeAI's whole strategy is to shift us from this siloed, chaotic past to a truly interoperable future. And the key enabler for this whole vision is what they call the Agent Communication Protocol, or ACP. The goal is a unified ecosystem where any agent built with any framework can talk to any other agent and collaborate on a standardized, commoditized platform. So the ultimate question this whole thing leaves us with is this.
Will this push for a universal standard, what is effectively an operating system for agents? Will it finally be the thing that brings order, that brings scalability, and brings sound engineering principles to what has been, up until now, the Wild West of AI agent development?